everyone, we are presenting the interim video of our project for Texas Instrument India's Innovation Challenge 2016. We are students from KVP College of Engineering, Satara. Our project name is Automatic Farm Watering System. Our team ID is 442. Our mentor is Mr. Rajan Devi sir. My team members are Shraddha Moite, Sharayu Nikam and Ashwini Patil. These are TI and non-TI parts that we used in our project. This is the block diagram for our project. In this project, we turns on and off the motor automatically according to the crop requirement, and the status of motor will send to the user's mobile through GSM module. This will save the farmer's important time so he can do another work also. At interim level, we use single phase motor and general purpose PCB for our project. This is power supply circuit that gives 12 volt output as an input to the relay and 5 volt output as an input to the soil moisture sensor. First, soil moisture sensor measures the water content in the soil, and its output, which is in volts, is given to the microcontroller, which is named as MSP430G2553. This is program for project. In this, we set a threshold value which will compare with the sensor output value, so the controller decides when the motor will turn on or off. Here is the sensor we mount in the soil to measure the water content in the soil. When the soil is dry, the motor is turned automatically on. We can also see the output on serial monitor. After certain time, when crop get required amount of water and soil wet at certain level, then suddenly motor turns off. This is part A of our project. In part B, we send the status of motor on the farmer's mobile through the GSM module. Here we consider only one type of crop, but by the IMB's suggestions, we can also perform programming for different types of crops. We are working on that. We had met some farmers to explain our project. If my farming is not by drip irrigation, then how can your product is helpful for us? Then we think on that and then we work on that, so we get some solution. If we increase number of sensors, then normal irrigation can be also possible by our project. So we can try and work on that. Our product is done successfully at primary level. We supply these by shops and distributors. When we get more market or more orders for our product, then we make it available by online shopping also. Another problem that the farmer tells us, in most of the products, the motor will be turned on and off by sending the SMS or by giving the missed call from the user's mobile through the GSM module of the project or product. But in most of the rural areas, there is problem of network. Because of that network failuring, there is problem to turn on and off the motor. So the farmer suggests us to overcome that problem. Hence, we also think and work on that, and we make it automatic to turn on and off the motor by using the soil moisture sensor. Because it is the interim demonstration video for our project, we use single phase motor, but in the final demonstration video we use the 3-phase motor, because most of the farmers uses 3-phase motor, and remaining parameters also completed or added in the final video. For example, dry run detection, water leakage detection, is there is electricity in the farm or not, so the farmer can save his important time, and this all the status will send on the user's mobile. But there is no effect of network failure because our project is fully automatic. I want to give thanks to Texas Instruments for giving this great opportunity to my team.